Imagine this. You wake up on a Saturday morning. You grab your phone, open ChatGPT, and type a question. Maybe it's a math problem. Maybe it's a homework assignment. Maybe you ask it to write a funny story about dinosaurs playing football. Only a few seconds later, the answer appears. It feels almost magical. Sometimes the answer is so good that it almost seems as if someone is sitting inside the computer, reading your question and carefully thinking about the best reply. But here's the strange part. There isn't a tiny person inside your computer. There isn't a brain. There isn't a mind. So what is actually happening? How can something answer millions of questions every day if it isn't thinking the way we do? Today we're going to discover one of the biggest secrets behind modern artificial intelligence. And the amazing thing is this. The secret is much simpler than most people imagine. In fact, by the end of this video, you'll know the basic idea behind ChatGPT. But first, let's play a game. Hello everyone and welcome back on my channel. If you are new here, welcome. I'm going to start a sentence. I want you to finish it before I do. Ready? The sun rises in the... What did you think? Most of you probably said east. That wasn't difficult. Let's try another one. Cats like to chase. Maybe you thought mice. Or perhaps balls. Both answers make sense. Now let's make it harder. Yesterday I forgot my... What comes next? Backpack? Homework? Lunch? Keys? There isn't only one correct answer anymore. Instead, there are several good possibilities. Your brain instantly considered many different endings before choosing one. Now here's an interesting question. How did you do that? Did you search every sentence you've ever heard? Did you open an invisible dictionary inside your head? Of course not. Your brain simply used everything it has learned from experience. You've heard thousands of conversations. You've read books. You've watched movies. You've talked to friends. Without even noticing it, your brain has become incredibly good at predicting what usually comes next. And that's something humans do all day long. Imagine you're walking into your classroom. The teacher is standing at the front. Everyone is sitting quietly. Books are open. What do you expect to happen next? Probably the lesson begins. Nobody told you. You simply predicted what usually happens. Or imagine you're outside. The sky becomes dark. Heavy clouds cover the sun. A cool wind starts blowing. What do you expect? Rain. Maybe not every time. But often enough that your brain has learned the pattern. Our lives are full of predictions. When someone smiles at you, you expect them to be friendly. When you hear the first notes of your favorite song, you already know what comes next. When someone says, happy, you almost automatically think, birthday. Your brain is constantly making tiny predictions without you even realizing it. Now here's the surprising connection. ChatGPT also makes predictions. But instead of predicting the weather, or what your teacher will say, or whether your football team will win, it predicts something much simpler. It predicts text. Just one small piece of text at a time. That's it. Really? If I asked someone, what is ChatGPT doing right now? The most accurate short answer would simply be, it's trying to guess what text should come next. At first, that doesn't sound very impressive. After all, how could guessing the next word possibly explain stories, homework help, computer code, jokes, recipes, poems, and conversations? It sounds impossible. But don't worry. By the end of this video, that impossible idea will make perfect sense. Let's try another experiment together. I'm going to read the beginning of a famous fairy tale. Don't say the answer out loud just yet. See if you can guess it in your head. Once upon a. You probably already know. Time. You didn't need to think very long. Now let's continue. Once upon a time there lived a king, princess, dragon, wizard. Again, there isn't only one possible answer. Some endings are simply more likely than others. Stories you've heard before help your brain decide. Notice what's happening. You're predicting. Exactly the same kind of prediction that ChatGPT makes. The difference is where the knowledge comes from. You learned from living. ChatGPT learned from reading. That's a very important difference. You have memories. You have feelings. You have experiences. You know what ice cream tastes like. You know what it feels like to fall off a bicycle. You know how exciting birthdays can be. ChatGPT has none of those experiences. It has never tasted chocolate. Never ridden a bike. Never celebrated a birthday. Everything it knows comes from patterns found in text. That doesn't mean it's pretending. It simply means it learned in a completely different way than people do. Now imagine a gigantic library. Not just a normal library. A library so enormous that it contains millions upon millions of books. Books about history, science, animals, cooking, sports, space, video games, fairy tales, mysteries, adventure stories, comics, news articles, websites, and conversations. Now imagine spending years reading that library. Eventually, you'd start noticing patterns. Certain words often appear together. Some sentences begin in similar ways. Questions usually receive answers. Stories have common structures. Jokes often have surprising endings. Without trying to memorize every sentence, you'd slowly develop an incredible feeling for how language works. That's much closer to what ChatGPT does. It doesn't remember every page exactly. Instead, it learns the patterns hidden inside all that writing. Think of it like listening to thousands of songs. Eventually, you begin to understand what makes music sound like music. You don't memorize every note. You recognize patterns. The same is true for language. So here's the big idea we'll keep coming back to throughout this video. ChatGPT doesn't start by thinking of an answer. It starts by asking one simple question. What is the most likely piece of text to come next? Then it answers that question. Immediately afterward, it asks exactly the same question again. And again. And again. One tiny prediction after another. Like placing one Lego brick on top of another. One brick isn't very exciting. But thousands of carefully placed bricks can become a castle. One prediction isn't very impressive. Millions of predictions can become a conversation that feels surprisingly intelligent. And that's exactly what we're going to explore next. Because now that we understand the basic idea, it's time to discover how a computer can learn these patterns in the first place, and why something as simple as predicting the next piece of text can create results that seem almost magical. Of course, the real ChatGPT learns from an enormous amount of text, far more than any person could ever read in a lifetime. But if we used billions of sentences, it would be impossible to understand what is happening. So instead, let's use a very small collection of sentences. Imagine that these are the only sentences our language model has ever seen. I am tired. I am hungry. I am sick. I am sad. I am finished. I am invited. I have time. I have hunger. I must study. I must leave. I can help. I will come. That's it. No books. No websites. No stories. No conversations. Only these 12 sentences. This tiny collection is our entire world. Now imagine we ask our language model a very simple question. The input is just one word. I. Nothing else. The model now has to guess what comes next. How should it make that decision? Well, the first thing it can do is look back at everything it has learned. It has seen 12 sentences. Let's examine the word that follows I in each one. The first sentence says, I am tired. So after I, we find am. The second sentence? Again, am. The third? Still am. If we continue through the list, something interesting appears. The word am appears 6 times. The word have appears twice. The word must appears twice. The word can appears once. And the word will appears once. Now let's organize those observations. Instead of looking at individual sentences, we simply count how often each word appears after I. The word am appears 6 times. Have 2 times. Must 2 times. Can 1 time. Will 1 time. Immediately, we begin to see a pattern. Some words appear much more often than others. And that's exactly what the language model is looking for. It isn't asking, which answer is correct? Instead, it asks, which answer seems most likely based on everything I've seen before? In our tiny dataset, the answer is clear. The word am appeared more often than any other word. So if the model has to make a prediction, am is the safest choice. Notice something very important. The model is not certain. It isn't saying, the next word must be am. It is saying something much more careful. Based on my experience, am is the most likely next word. Those are 2 very different ideas. Think about weather forecasts. If a weather report says there is an 80% chance of rain tomorrow, does that guarantee rain? No. Sometimes it still stays sunny. An 80% chance simply means that rain is much more likely than clear skies. Language models work in a very similar way. Every prediction is really a question of probability. Some words are more likely. Some are less likely. Very few are impossible. Now let's imagine something different. Suppose our tiny dataset looked like this instead. I play football. I play basketball. I play chess. I play tennis. Now the model receives the input. I. Would it predict am? Of course not. It has never seen I am before. Every sentence begins with I play. So this time, play becomes the most likely prediction. Nothing inside the model has changed. Only the examples it learned from have changed. And because the examples changed, the prediction changes as well. This is one of the most important ideas in the entire video. A language model learns from patterns. If the patterns change, the predictions change. That's why the quality of what the model learns from matters so much. The better the examples, the better the predictions. Now let's take one more step. Suppose our model has already predicted am. The sentence now reads, I am. Once again, the model has to decide what comes next. Should it choose tired, hungry, sad, finished, invited, or sick? It repeats exactly the same process. It looks back through everything it has learned. It counts the possibilities. It estimates which continuation is most likely. Then it makes another prediction. Notice what's happening. The model isn't writing an entire sentence all at once. It doesn't think, I'm going to write I am tired. Instead, it builds the sentence one small step at a time. First, I. Then, am. Then, tired. Each prediction creates a slightly longer sentence. That longer sentence becomes the new information the model uses for the next prediction. One prediction leads to another. Then another. Then another. Eventually, a complete sentence appears. But there is one small problem. Up until now, we've been talking about words. We've counted words. We've predicted words. We've built sentences using words. But real language models don't actually work with whole words. Instead, they work with something called tokens. At first glance, tokens look very similar to words. But they aren't always the same thing. And understanding that difference is the next important step in discovering how ChatGPT really works. A token is simply a small piece of text. Sometimes a token is an entire word. For example, the word house might be stored as a single token. The word apple might also be a single token. In those cases, words and tokens are exactly the same. But not always. Let's look at a longer word. Suppose we have the word playing. Instead of treating it as one single unit, the language model might split it into two tokens. The first token could be play. The second token could be ing. Together, those two tokens still form the same word. But now the model has learned something useful. It already knows the meaning of play. It also knows that ing is often added to verbs to describe an action that is happening right now. So even if the model has never seen the exact word playing before, it can still understand it by combining two familiar pieces. Let's try another example. Imagine the word unbelievable. That's quite a long word. Instead of treating it as one giant piece, the model could divide it into several smaller parts. Perhaps something like believe and able. Again, each piece has its own meaning. When combined, they create the complete word. You can think of tokens as being a little like Lego bricks. Imagine you wanted to build a spaceship. You wouldn't manufacture one enormous Lego block shaped exactly like a spaceship. Instead, you would use hundreds of smaller bricks. Those same bricks could also build a castle, or a car, or a robot. Because the pieces can be reused in many different ways. Tokens work in a similar way. Instead of storing every possible word separately, the model stores many smaller pieces that can be combined to create millions of different words. This makes the system much more flexible. It also helps when people invent new words. Think about how quickly language changes. Every year, new names, products, games, and internet slang appear. If the model only knew complete words, it would constantly encounter words it had never seen before. But because it understands smaller pieces, it can often make sense of new words by breaking them apart. The same idea also works for names. Imagine someone invents a completely new company called StarPixel. Even if the model has never seen that exact name before, it already knows words like star and pixel. Those familiar pieces help it understand the new word much better than if it had to treat the entire name as something completely unknown. Now here's another interesting example. Think about these words: is, was, were, be. At first glance, they all look different. But if you've studied English grammar, you know they're closely related. They're all different forms of the same verb. The language model gradually learns these relationships from the text it reads. It notices that these words often appear in similar situations. That helps it make better predictions later. The important thing to remember is this: the model isn't thinking, "This is a verb," or "This is the past tense." Instead, it notices that certain pieces of text often behave in similar ways. Once again, it's learning patterns. The same idea we've seen throughout this video. Only now, those patterns are built from tokens instead of complete words. Now that we understand tokens, we can finally watch the language model generate an actual sentence. And this is where everything we've learned starts coming together. Generating a sentence. Imagine you've just typed the following sentence into ChatGPT. Last week I wasn't there. Now you press enter. The language model reads the entire sentence. Not just the last word. Not just the last two words. It considers the complete text you've written so far. Its task hasn't changed. It still asks exactly the same question we've been talking about throughout this video. What should come next? Notice something important. The model doesn't immediately create an entire paragraph. It doesn't suddenly decide on the whole answer. Instead, it begins with just one prediction. Only one. At this moment, there are thousands of possible tokens it could choose. Perhaps the next sentence begins with I, or, because, or, then, or, so. Each possibility has a different probability. The model compares all of them. Then it chooses the one that seems most likely. Suppose the model predicts the token I. Now our text becomes last week I wasn't there. I. That's all we've added. Just one token. The sentence still isn't finished. So what happens next? The language model immediately asks the same question again. Given everything I've written so far, what should come next? Notice how the context has changed. A moment ago, the last thing the model saw wasn't there. Now it also sees I. That new token becomes part of the context. And because the context has changed, the probabilities change too. Perhaps now the most likely continuation is was. The text becomes last week I wasn't there. I was. Still, the sentence isn't complete. So the model repeats exactly the same process again. One prediction. Then another. Then another. It never jumps ahead. It never writes the entire paragraph in one giant step. Instead, it slowly builds the answer, one token at a time. And that's the remarkable part. When you're reading the final answer on your screen, it feels as though ChatGPT thought of the whole response first and then typed it out. But that's not what happened. The paragraph you're reading didn't exist a moment earlier. It was built gradually. One tiny prediction after another. Just like building a wall by laying one brick at a time. Each brick may seem unimportant on its own. But together, they create something much larger. But we're still missing one important piece of the puzzle. So far, we've talked about choosing the next token. But how does the model decide which parts of the previous sentence are most important when making that prediction? After all, not every earlier word matters equally. Some words provide much more useful information than others. And that's exactly what we'll explore next. Imagine I simply showed you these words. I was. What could come next? I was hungry. I was late. I was excited. I was tired. I was sick. There are many good answers. Now let's add a little more information. Last week, I wasn't there. I was. Suddenly, your prediction changes. Now, words like sick, traveling, or busy seem much more likely than before. Why? Because the earlier words give us clues. Last week tells us we're talking about something in the past. I wasn't there tells us that someone was absent. Together, those clues help narrow down the possibilities. The more useful information we have, the better our prediction becomes. And that's exactly what a language model does. It doesn't treat every previous word as equally important. Some words provide very little information. Others completely change the meaning of the sentence. Imagine someone asks you, "Can you open the?" You might think of a door. Now suppose they continue. "Can you open the web browser?" Now you aren't thinking about a door anymore. Just a few extra words completely changed what you expected. Language works this way all the time. Every new word adds a little more context. And every new piece of context helps the model make a better prediction. So although a language model predicts only one token at a time, every prediction is based on everything that came before it. That said, does a language model actually think? The answer depends on what we mean by thinking. If thinking means making predictions based on patterns, then yes, a language model is remarkably good at that. But if thinking means having experiences, having feelings, having goals, or understanding the world the way people do, then the answer is no. Everything it knows comes from patterns in language. When you ask it a question, it doesn't search its own memories. Instead, it looks at your words, recognizes familiar patterns, and predicts the most likely next token. One token. Then another. Then another. Until those tiny predictions become a complete answer. It's a bit like building a huge picture out of thousands of tiny puzzle pieces. One piece doesn't show much. But when every piece is placed in the right position, a complete picture appears. One prediction isn't very interesting. Thousands of predictions together become a conversation. Let's quickly remember the most important ideas from today's video. A language model learns patterns from enormous amounts of text. It doesn't memorize every sentence. Instead, it learns which pieces of language usually appear together. It doesn't work with whole ideas. It works with tokens, which are small pieces of text. Every time you type a prompt, the model asks one simple question. What is the most likely next token? It chooses one, adds it to the sentence, then asks exactly the same question again. One prediction after another. The previous words provide context. That context helps the model make better predictions. And by repeating this simple process over and over again, it can write stories, answer questions, translate languages, explain science, and even help people learn new things. The next time you chat with an AI, remember what's happening behind the scenes. Millions of mathematical calculations work together to answer one simple question over and over again. What comes next? And somehow, those tiny predictions become conversations. They become explanations. They become stories. They become ideas. But AI is still just a tool. Like any tool, it can make mistakes. Sometimes the information it gives you will be excellent. Sometimes it will be incomplete. And sometimes it may simply be wrong. That's why you should never accept an AI-generated answer without thinking about it. If the information is important for school, for work, or for making a decision, take a moment to verify it using reliable sources. The best way to use AI isn't to replace your own thinking. It's to challenge your thinking, spark your curiosity, and help you learn. After all, technology is at its most powerful when it helps people become smarter. If you enjoyed this video and learned something new, don't forget to like, share, and leave a comment below. I'd love to hear what surprised you the most. And if you don't want to miss future videos about programming, artificial intelligence, and the technology shaping our world, be sure to subscribe and turn on notifications. Thanks so much for watching. See you in the next one. And as always, happy coding and happy debugging with K-Tips.